Hello everyone, this is Srithi Suteri, and today we are discussing this problem that is maximize distance to the closest person. So this is the problem description. If you want to read this, you can pause the video. But since I've already read this description, let me give you the brief information this description has, and let's discuss the example as well. So the description says that you are given with an array of seats wherein each occupied seat is represented by 1 and each unoccupied seat is represented by 0. And one more important thing to note here is that at least one seat is occupied and at least one seat is unoccupied, right? Obviously, this will be zero indexes, zero based indexed, and there is a person called Alex and he wants to sit on any of these unoccupied seat, provided that he will be enjoying a situation wherein the distance from him and the closest person that is already seated should be maximum, right? So what I'm going to say here is that suppose Alex want to sit on this index, right? So in this situation, the closest person from him would be the zeroth index person, and the distance between them is 1, right? And suppose let's take another example that Alex wants to sit on this situation. So from this seat, the maximum distance between the person is, or the closest person from him is either this zeroth index person or this fourth index person. In both of the cases, the maximum distance between them is 2, right? Again, another case that if Alex sits on this index, right? Again, the minimum distance is 1 in this case. Again, if Alex sits on this position, the maximum distance from the closest person would be 1, right? So in all of these cases, this is the maximum distance that he enjoys while sitting on this situation, second seat, right? So for that case, we will return this maximum distance. So the answer for that case would be 2. You can see this output of this example that we have to return this maximum distance possible from Alex and the closest person between him. So I hope I've made this example clear to you guys. If you want to look at other examples, so you can also look at them, right? In this situation, the only first index is occupied and the rest of the indexes are empty. So if Alice sits on this index, so he will enjoy the maximum distance between this 1, 2, and 3, right? So for that example, we have returned 3 as our answer. So I thought I've made this example clear. So now let's jump into whiteboard and let's see what all can we do to solve this problem. So this was the example that I discussed with you. So let's just divide this problem into further cases, right? So what all could be the possible cases while we are dealing with this seating arrangement, right? The first case would be that suppose the starting indexes are free or the starting seats are unoccupied and there is only one person sitting at this last index, right? So for that case, let's not just discuss about what would be the maximum distance between him or Alex, but just take an example that this could be one such case, right? That starting indexes are unoccupied. Another such example could be that suppose some person is sitting at the end, at the start, and some other person is also sitting at the end, and middle seats are unoccupied. Middle seats unoccupied, whatever the spelling is. The third case could be that the starting one person is starting at the sitting at the start and the rest of this indexes are unoccupied. Ending seats unoccupied, right? So these all could be the cases in this bigger example, right? Also now you will say that there could be an example that will combine all of these three cases and another scenarios, right? So yes, there could be cases like if you see this example, let me modify this further. Let's just remove these values because we are adding some values in between. So suppose that 2 seats are vacant at the start and some seats are also vacant at the end, right? So if you look closely into this situation, you can see that this all section consists of case 1. This all section from here till here consists of case 2, and this all section from here to here is consist of case 3, right? So what I'm trying to say here is we will break down this row or this array, and we will try to locate these 3 individual cases, and we will find out the maximum distance possible from case 1. Maximum distance, let's call this maximum 1, this maximum 2, and this maximum 3. And then after dealing with all these individual cases, we will find out the maximum from maximum 1, maximum 2, and maximum 3, and we will return our answer as maximum distance, or whatever the variable you are taking is, right? So I hope I am making sense with this now. Now let's look upon each cases and how we will get the answer for each cases, right? So I hope you are able to digest this situation. If not, don't worry, we will discuss each case in detail, and we will then look upon the code example, and we will then find out what will happen, right? So this is the case that this is the detailed example that I have wrote here. So let's discuss these situations. So obviously the first case that we discussed was कि some empty seats are there in the starting of this row. So in this case, also I forgot to tell you guys this, that we are maintaining 2 variables. The first could be the last seated person, or the last seated variable, right? And the second could be the current index. So what will be the purpose of last seated is we will locate, or we will keep in mind that what was the position of the last person that was sitting in our array or the row. Initially, we will take it as -1, and current would be we will use this to iterate over our rows, right? So in this situation, if the last seated index is -1, since no person is sitting till this third position, in this case, you can obviously tell that Alex will enjoy the maximum distance when he will sit at this first index, right? And since we don't have to return the index at where he is sitting, we just have to return the maximum distance possible in this case. So obviously the maximum distance possible in this case would be we will simply return the first seated index for this situation, right? If no other person is sitting from the start. And how we will be going to find out, we will look later in this, we will look this situation later in the code, right? So for that, we have to simply return the first seated index. The first seated index is 3 in this case, so we will return 3 as the maximum distance possible in this case, right? Let's now first of all look the third case, and then we will discuss the middle case. The third case would obviously be that suppose some person is sitting at the start and end indexes are free, right? Obviously Alex will enjoy the maximum distance when he will sit at the last index. And to get this maximum distance, what we have to do is we simply have to return the distance between them. So the last index position would always be n-1, because n is the total size of this array, and the array is 0 base index. So n-1 with the last index, and we will subtract this with the last seated index, right? So in this situation, you can see that n-1 would be 4, and 4 minus the last seated index was 0, right? So this 4 minus 0 would be 4. So this will be our answer, right? So I hope these two cases are clear to you guys now. Now let's look upon this cases where some starting seat or some end seat is already occupied, and Alex has to sit on these middle seats, right? So what could be the maximum distance he can enjoy? So there is one such simple way of finding out, that suppose some k consecutive seats are empty for him to sit. So in that case, what you can do is you can simply add, you can simply do this k plus 1 by 2, and the value you get will be the maximum distance he can enjoy, right? So in this case, you can see that 3 consecutive empty seats are there. So you can do 3 plus 1 by 2, that would give 2, right? So if Alex sits at this index, he will enjoy a distance of 2 from this position, also 2 from this position, right? So 2 will be our answer in this case, right? If you want to take another examples as well, if you can, you are free to take that. Let me give you another example. So suppose 0, 1, 2, 3, 4, and 5. And in this case, 0th and 5th index are already occupied. So you can see that Alex can either sit on this index. If Alex sits on this index, the minimum distance or the closest person from him would be this 0th index, and the maximum distance he can enjoy is 2. Similarly, from this position, he can enjoy a distance of 3, but closest person is this, right? So answer would be 2 in this case. Another case could be that if Alex sits on this index, again, this situation would be reversed, that this would be the closest person of distance 2, and this would be the closest, the farthest person with distance 3. But again, we have to find the maximum distance between the closest person and the Alex. So again, the answer in that case would be true, 2 as well. So I hope I'm making sense with this middle case now. And if you are clear with these three cases, we simply just have to traverse the array, and we have to keep in mind about the last seated index, and we will be able to solve this problem, right? So let's jump into the code, and let's see what we have implemented in here. So obviously, first of all, let's take the pen. The last seated index would be -1, because we don't know that if we have any person sitting at the index or not, and n for the total number of length of this array, and the maximum distance is 0 in the start, right? So this is the basic traversal, so this is the loop for traversing in the array, and this is the case if we find out that any seat is occupied, right? 1, because I've already told you that if any seat is occupied, then its value is 1 in this array, right? So if any seat is occupied, there could be two cases, right? The first is that existing seats are vacant, or you can see that the last index was -1, right? So if this is the case 1, what we will do is we will simply reserve our maximum distance as I. Why I've already told you in this, just a minute, right? So I have already told you with this example, with these possible cases. So if this is the case, we will reserve my maximum distance as this. If this is not the case, if this is not person that we have encountered, so what we will do is we will do this middle wala formula, right? This is the middle case, right? The case 2. So this is our middle wala case, and again we will check that we have to get the maximum value, right? So we will check with this value that we get from the middle case and the existing maximum distance, and we will take the maximum into this maximum distance, right? Also, since we found a person seated at the current index, we will update our last seated with this current index, right? So I hope I'm making sense with this inner loop now, or this inner statement now. And if this all loop is executed successfully, we will also be able to find out the situation that if we reaches at the end distance, at the last array, and if that is vacant, if that is not occupied, so there is another chance that Alex can sit on this index and can enjoy the maximum distance. So for this case, we have handled this simple example that I have already told you in this possible case number 3, right? So this case herein we have discussed this thing, and if these all things we have checked across case 1, case 2, and case 3, and all of these situation, we will able to get maximum distance in this variable, and after that we will simply return this maximum distance, right? So I hope I'm making sense with this code now. If I'm not clear with this code, if you are not clear with this code, you can dry run this once, you will definitely get this. Now let's submit this code, and let's see if we able to submit this or not. Right, so it got submitted, and I hope you enjoyed my explanation, and if you like this explanation, you can like the video and you can subscribe to the channel as well. So that's all for today, guys. Thank you.